Okay, hi, BC Part 1. Please grab that handout from class. And what I'd like you to do right now is question number 1. Go ahead and do parts A, B, and C, and then come revisit me for the answers. And what I'd like you to actually try and do with A, B, and C is to answer those 3 without having to go and graph. Okay, so just see if you can answer those 3 just by what's called by inspection, by just looking at them, and then replay me when you have your answers so you can check. Okay, now here are my answers. Here are the answers, okay, for part A. A and B, the domain is the same for both, because in part B, shifting that function down 7 does not affect the domain. Part C, though, the range of the original function, which is the parent function, I'll call it here, and I know you're thinking, wait, parent function is just like f of x equals sine x. I mean, yes, you're right, but I just called the parent here the function that is being transformed, okay? So the parent function had this range. If everything is shifted down 7, the range will absolutely be affected, and here's the new range. Now that I'm thinking of it, boys and girls, I actually don't know why I'm doing a screencast for this, because you don't need a screencast for any of this. Let me see. Like none of it. Oh yeah, number 3 in the back page. Okay, that's right. All right, why don't we here, why don't you just finish D, E, and F and then check with me on the screencast, okay? And then I'm gonna probably send you on your way, and but just go ahead and do D, E, and F and then replay me. Okay, here are the answers for D, E, and F. Okay, D was straightforward. Here's E, right? Negative f of x reflects f of x over the x-axis. So this is the range. Absolute value of f of x reflects everything below the x-axis to being above the x-axis. So here's the range. And then part 2, question number 2, you can do on your own. It's slightly more tricky, but actually no, that's wrong. It's not really more tricky at all. Well, maybe a little bit. Okay, but go ahead. 2 is for homework, so number 2 on that page. And here's what I want to talk about with the back page. All right, I'm not going to necessarily do out the back page. I'm curious to see what you'll do with it. So question number 3, it's asking you to solve for x, right? And we've got this, okay? And remember, we just let, here's what I want to tell you. This is why I want to do a screencast. Okay, my gosh, I'm so scattered, boys and girls, sorry. This notation right here, this is actually precisely why. You see how this is cos squared x, all right? When you see cos squared x, that means the same thing as the cosine of x squared, all right? It's just more conventional. It's just conventionally, and it's frankly easier because it requires less pen strokes, frankly. Cos squared x means cos x squared, all right? So get used to seeing, cosine x or sine x raised to a power written this way. Now, not to be confused, though, with something like this, the cosine of x squared, all right? So just pay attention to where the squared is. In fact, Microsoft Word called both question number 3 question 3. But the last question deals with the sine of an angle, and that angle is x squared equaling 1/3, okay? So that's why I wanted the screencast. This was such a kind of a waste of breath in doing this screencast now that I think about it. But one is just to bring to your attention this new notation right here. The second one is to remember that when we did solved equations like this that were trigonometric and also quadratic, we did this substitution. We let u equal cosine x. When you substitute in u here, you're going to get a quadratic equation. The quadratic equation that I think we did in class ended up being factorable, right? Okay. This quadratic equation is not factorable. So this is going to ask you, do you remember how to solve quadratic equations if they were not factorable? Yes, hopefully you're saying, oh, right, the quadratic formula or completing the square, okay? For both questions 3, you can use your calculator only for the quote-unquote first part, okay? And you know what that means when I kind of mandated just like the first part use of calculator in class. All right, so actually that's it. This is actually a screencast that never had to be a screencast. So because I'm looking at this handout and I was thinking, why did I have to do this? But But I guess it's always fun to work together. All right, my cake eating smart people, have a great evening. Goodbye.